I'm here with Gwendolyn Woods, who is a grad student at the University of Arizona. She's studying environmental engineering, and she's here at the 2011 ICOSSE conference to talk to us about optimizing distributed wastewater reclamation capacity in Tucson, Arizona. So go ahead, Gwendolyn, talk to us about your research.
Thanks. The project that I'm working on is comparing decentralized treatment systems for wastewater to more centralized, larger systems. And so what we're comparing is sort of an economy of scale with a larger wastewater treatment facility with an increased amount of wastewater collection infrastructure and reclaimed water distribution infrastructure versus like a smaller plant that's going to have less piping but may cost more per gallon to treat the water. And so we're using an Excel spreadsheet calculator that calculates all the different costs associated with not only reclaimed water distribution but also potable water and wastewater collection, so that we can compare the effect of water reclamation on potable water and wastewater collection. And using that, we've applied this calculator to the southeast part of Tucson, in an area called the HAMP, which is the Houghton Area Master Plan region. And we've developed several scenarios that look at different aspects of water reclamation. So our base scenario is with no reclamation, where all water would be potable, and that is drinkable water. And then our next scenario is with regional reclamation, using a larger centralized plant that's already here in Tucson, but at the northwest end of town, which is about 25 miles away from our study area. And then our other scenarios utilize a small wastewater treatment plant that would be located very near the HAMP and would either send water to the HAMP and to groundwater for recharging the groundwater, or it would just be a smaller plant that would supply only reclaimed water to the HAMP. And then our final scenario uses the water from the wastewater treatment plant to augment potable groundwater supplies and then resupply those to the HAMP area after a period of time in the ground. And what we found is that actually the cheapest option is probably the indirect potable reuse. But there's a trade-off there in possibly quality of that water, as sometimes contaminants can accumulate in wastewater treatment plants and then travel into groundwater. And then our other scenarios are fairly similar. What we found with the regional reclamation is it depends a lot on existing infrastructure, whether there's already a line there or not. If there is infrastructure going to the study area and it has capacity, then that can be a very cost-effective option. And if not, it can tend to be more expensive. And I think that's all I have.